I'm going to talk to you about the 4D data built-in encryption solution. The main goal of this demo is to understand how it works. It can work in a very easy and automatic mode, but you can also build fully customized solution. And together we will have an overview of all this. I am Marie-Sophie. I've been with 4D since November 2017 in the product team. This is the agenda. First, we will talk about the why. Why do we have this 4D data built-in encryption solution? We will talk about the main concepts. We will have a lot of details about the strength of this solution. We will run a demo with the MSC, and at the end, we will learn how to handle 4D data encryption with 4D commands. Let's start with the first section about the why. Today, your customer data must be guarded against threats. Your applications may be hosted in an unsafe place or on the cloud. Of course, encryption is not required by GDPR, but it's recommended. You could encrypt your whole disk, but if you do that, you need to give your disk password to your machine's administrator. And if you copy your data file elsewhere, you will get, again, non-encrypted data. So fortunately, there is the 4D data built-in encryption solution. It is dedicated to your 4D data. Even if you copy your data file elsewhere, it will remain protected. And this solution is completely suited to your 4D way of coding. The next section is about the main concepts. Just some technical figures before going on. The algorithm is advanced encryption standard. About the impacts with the performance, we have a 2 to 2.5 factor for a classic disk, for a cold read, so for data not in cache. We have a 4 factor on a SSD disk, and we have a 0 factor for cache data, and the external data is out of scope. The 4D encryption tools are based on a passphrase. What's a passphrase? It is a sentence or a combination of words. And from this passphrase, a binary encryption key is obtained to encrypt the data. Later, I will talk only about encryption key to say binary encryption key. What does an encryption key look like? Here we have a passphrase, happy with 4D, exclamation mark, and there is a binary encryption key obtained from this passphrase. It is an object with an encoded key property, and this is the JSON representation of this object. All the files where we can find data are impacted. So this solution impacts the data file, the index file, and the journal file. The 4D encryption is performed at table level, so it allows you to disable encryption for tables not containing sensitive data. Here, in this example, we encrypt only the confidential information table. This encryption is symmetrical. It means the same encryption key is used for encrypting data and decrypting data. And the same key is used for data, index, and journal files. The next section is about all the strengths of this 4D data encryption solution. First, selecting the tables to encrypt has no correlation with the encryption process. The first step is to select the tables you want to encrypt. For this, you go in design mode, and there is for this a new checkbox. This is the encrypt table checkbox. And no encryption action is run here. You can still work with your database. Then comes the step 2. When you are ready to encrypt your data, you choose a passphrase and you run the encryption process. Your original files are saved in a separate folder, and you get a data and an index file, and those files are encrypted. Data in tables marked as encryptable are now encrypted, There is no journal here. You will be asked to create a new journal when opening the database. It's like a backup. Then, after the step 2, once your data is encrypted, you must provide the valid encryption key to work with your encrypted data. How to run this encryption process? First, you can use the MSC. It is the easiest and most automatic solution, and you can also use new4d commands. To provide the valid encryption key to work with your 4D data, you can use a flash drive, and you can also use new4d commands. And to put the encryption key on a flash drive, you can use the MSC, and you can use the new4d commands. And remember, at any time, you can change your encryption key or decrypt the data. Once you provide the valid encryption key, then data is automatically encrypted on disk and decrypted in memory. And for this, no need to update code. It is fully automatic. If no encryption key is provided, access to non-encrypted data is still possible. In this example, no encryption key has been provided. We can't access the confidential information table, which is encrypted, but we can still access the client's information table, which is not encrypted. An important strength is the 4D keychain. Each time a valid encryption key is provided for data, it is added to the keychain. And this keychain is in the memory on the server. Here, a user opens a data file, an encrypted data file. They provide the valid encryption key. It is added to the 4D keychain. When we go on, we open another encrypted data file. We provide the valid encryption key. It is added in the keychain. And when an encrypted data file is opened, 4D automatically looks for a valid key in this keychain. Here, a user opens an encrypted data file. 4D looks for a valid key in the keychain. It is found, and so access to encrypted data is granted. This keychain is emptied when you quit 4D. Another important strength is that there is an automatic search for a valid key on devices. If no valid encryption key is found in the keychain, then 4D searches at the root level of connected devices, for example, a flash drive. Here, we open an encrypted data file. We have some encryption keys in the keychain, but not the valid one. And we have some connected device, like a flash drive. And on this flash drive, we have the valid encryption key. 4D finds it, it is added in the keychain. Access to encrypted data is granted, and if we need, we can unplug the device. And this is very useful if you change your encryption key, if you make some backups. It allows you to keep the history of all your encryption keys on a flash drive. Then you don't have to memorize them, and you don't have to provide the valid encryption key if you restore backup. So it's very useful to keep all your history with encryption keys. We have seen a lot of things, so let's take a break to draw conclusions. Once the data is encrypted, the only thing to do is to provide the valid encryption key. For this, no need to update code, because providing this key can be as easy as plugging a flash drive. Of course, there are other solutions detailed later. And the next section is about the MSC. And for this, I propose running a demo. So let's work now with a simple demo on the MSC. We will work with this database containing two tables. We have the confidential information tables containing the client's names and the comments we wrote about them. And we have the client's information table containing figures such as total sales or discount rate. We can verify the data. Here is the client list with name, commands, and with the figures. We are going to encrypt only this table, confidential information, because it contains the client's name. And we don't encrypt this one, client's information, because it contains only figures which are meaningless without the client's name. If someone steals this encrypted database, they won't access the client name, they will have only figures which won't give any advantage. So for this, we go in the structure and we check encryptable here for this table. And we can verify here, nothing is encrypted for the moment. We can still access the data. And if we go into the MSC to check the journal, we can view the data related to the confidential information table. Nothing is encrypted for the moment. Here we have a new encrypt page. There is a warning here because we have an encryptable table containing non-encrypted data. So the warning says there is something to do with encryption. When you're ready to encrypt your data, you click on this button and you enter the passphrase. There is here a passphrase security level indicator, and we enter this passphrase twice. And here 4D restarts in maintenance mode because we can't encrypt a data file while it is opened. And we are asked here to save the encryption key. So I'm going to mount a flash drive to save the encryption key on it. I answer yes, and I save the encryption key at the root level on the flash drive. And let's check the encryption key. Here is the file containing the binary encryption key. The extension of the files for encryption keys is .4d Keychain, and we can verify its content with TextEdit, for example. Here is the binary encryption key obtained from the passphrase happy with 4D. It is an object with an encoded key property, so this is the JSON representation of the object. And now let's have a look at the database itself. Here, original files have been saved in this folder named Replace File Encrypting with the date. And here we have the encrypted data file and the encrypted index file. And we have no journal here. We will be asked to create a new journal when we open the database. So now let's start working with our new encrypted database. So I quit 4D here and I unmount the flash drive. And let's open again the database. So now we open an encrypted data file without providing any encryption key. So I open the database. We are asked to create a new journal, and I create it near the data file. And if we want to activate it now, we click OK. So here we have opened an encrypted data file without providing any encryption key. And let's check what happens. Encrypted data is not visible, it's not accessible, but unencrypted data is still visible. And if we try to create, for example, a new client, we can't because the encryption key is missing. Now let's mount the flash drive. And let's open again the encrypted data file. So remember, when we open a data file, 4D automatically searches for a valid encryption key on a device like a flash drive. So we open again the data file. Let's check what happens. And now encrypted data is visible and accessible because the valid encryption key has been provided on the flash drive. And we can try to save a new client. And we can't. So we can read and write the encrypted data. And let's check the journal in the MSC. We can view the data related to the encrypted table because the valid encryption key has been provided. And on the Encrypt page here, we have a button to change the passphrase if we need, and a button to decrypt the data. So the conclusion here is, once your data is encrypted, you need to provide the valid encryption key. And for this, you don't need to update code. Here, we did not update any code. And providing the valid encryption key is as easy as plugging a flash drive. It's one solution amongst others, and of course there are other solution details later. So let's go back to the slides. Part is about handling your 4D data encryption with the new 4D commands. Now we have a new set of commands to build fully customized solutions with encryption. Of course, there is a command to encrypt a data file. We have also a command to provide encryption key to data file. There is a command to generate a binary encryption key. There is also the register data key command to put an encryption key in the keychain. And there are commands to verify the encryption status of data. And for this, I propose running a demo. We are going to run this demo to learn how the data encryption commands work. They allow building fully customized user interfaces to manage encrypted data. Here on the first page, we have the same simple database as before, and we are going to encrypt the same client confidential information as before for the same reason. It is marked as encryptable. All the data files we will handle through this demo match this structure. Let's go on page 2. We are going to use the encrypt data file command, which purpose is to encrypt a data file. This command must be run on a non-opened data file, and we are going to encrypt the data file to be encrypted.4dd, which is near the current opened data file. We indicate its path name, and we also indicate the structure file path name, because remember, tables which are encryptable are marked in the structure. And we must also indicate the passphrase. So for the demo, I use a very short and simple passphrase, A. I copy it in the passboard, and we can run the encrypt data file command to encrypt the data file to be encrypted.4dd with this passphrase A. The data file is now encrypted. It will be open when we go on the next page. So let's go on the next page. Here you can see the encrypted data file. Let's have a close look at it. The encrypted data is not displayed in the list box because the encryption key has not been provided yet, and the non-encrypted data is available. There is a member method, encryption status, available on the main data store object returned by the ds command. It gives encryption information about the current open data file. It returns an object with properties. There is the isEncrypted property. It is true if a data file is encrypted. Key provided is true if the data file is encrypted and the valid encryption key has been provided. And there is a tables property. It's an object containing as many properties as we have encryptable or encrypted tables. We can check now. We are on an encrypted data file because isEncrypted is true. The encryption key has not been provided yet because key provided is false. And we can verify here the client confidential information table is encryptable and its data is encrypted. And let's have a look at the provide data key member method, also available on the main data store object returned by the ds command. It can receive a passphrase as parameter in order to provide the database with the corresponding encryption key. So first, let's call this member method with a wrong passphrase. Let's try it and let's see what happens. This member method returns an object with properties success. Success is true if the data encryption key matches the encrypted data. And status text errors are returned if the encryption key does not match the data. So we can verify success is false because the passphrase we gave is wrong, and in the errors collection we have the encryption key does not match the data, and the encrypted data is still not visible in the list box. Now let's call this member method with the right passphrase with A. The encrypted data is now displayed in the list box, and we can verify here success is true because the encryption key is valid, and we no longer have error message. The conclusion for this part is if you don't want to use the MSC to encrypt your data, you can use this encrypt data file command to do it on your own. And if you don't want to provide the encryption key on a flash drive, like we saw before, you can use this provide data key member method to build your own user interface, asking the administrator or the user to enter the passphrase. Let's go on the next part. We work here with another data file, encrypted data file.4dd. This data file is not opened and it has been encrypted with the encryption key got from the passphrase happy key. The data file encryption status command provides encryption information about a non-opened data file. It returns the same object as we saw before with the encryption status member method. We must pass the data file path name and the structure file path name. Let's check the status. We can verify the data is encrypted because is encrypted is true. The encryption key has not been provided yet because key provided is false, and the client confidential information table is encryptable and its data is encrypted. Let's now have a look at this register data key command. It allows to put an encryption key in the 4D key chain. So later, when you open your data file, you won't need to provide the key because 4D automatically searches for a valid encryption key in this keychain when 4D opens a data file. So let's put the encryption key got from the passphrase happy key in the keychain. It is now in the keychain and we can check the status again. And we can verify we have now key provided is true because the encryption key has been provided. And going on the next page, we'll open this encrypted data file. So let's go on the next page. We can verify the encrypted data is displayed and available in the list box because the valid encryption key has been found in the keychain. The conclusion for this part is that you can inspect the encryption status of a non-opened data file, and you can also put in advance an encryption key in the keychain. So when you open the data file, access to encrypted data is automatically granted. Let's go on page 6 and let's take a look at how to generate a binary encryption key with the new data key command. This command allows to generate a binary encryption key from a passphrase. For this demo, let's use a simple and short passphrase, B, and let's call the command. It returns an object with an encoded key property. This is the binary encryption key got from the passphrase. And on the next page, we will put this into action. So let's go on the next page. Now we have another encrypted data file. We have opened this encrypted data file 2.4dd. It is opened and it is encrypted from the passphrase very happy key. Since the encryption key is not in the keychain, we don't have access to encrypted data. And here is the scenario we are going to play. First, we are going to plug a flash drive, and second, we are going to generate the binary encryption key corresponding to the very happy key passphrase, and we will write it on a flash drive. So we will be in the case where the user opens a data file but forgot to plug their flash drive containing the encryption key. And we are going to see what happens. So let's mount the flash drive. We detect it, we select it, and we generate the binary encryption key corresponding to the very happy key passphrase. And here we write it on the flash drive. And we can verify the flash drive. Here is the encryption key file with the extension .4d Keychain. I open it with text edit. This is the JSON representation of the binary encryption key. It's the same, an object with an encoded key property. Now let's have a look at this discover data key command. This command looks for a valid data encryption key on plugged device. So let's call it. And the encryption key is now provided. It has been found on the device and access to encrypted data is granted. The conclusion for this last part is that if you forgot to connect your device containing the encryption key before opening the data file, don't panic. You can use this discover data key command to get the key. You don't need to reopen again the data file. And thank you for listening and watching. It was a pleasure for me to make this session.